today's program becomes even more special with your gracious presence among us. I once again extend a heartfelt welcome to our esteemed chief guest, Mrs. Vimala Saravanan Madam. Finally, I warmly welcome Mrs. Manjula Selvam, co-scientist, REST Labs, and today's speaker, Mrs. Chitra Periyasamy, associate scientist, REST Labs. I welcome you, ma'am. I am Mrs. Sonia Sriram, and it's my privilege to host today current affairs session. Such programs play an important role in broadening our perspective and reminding us of these foundational ideas that continue to influence modern research and innovation. The topic for today's session is green chemistry. Green chemistry focuses on pollution prevention by designing chemical processes that reduce or eliminate hazardous waste at the source. It promotes safer and non-toxic chemicals to protect human health and the environment by emphasizing waste minimization and auto economy. It improves efficiency and reduces byproducts. Green chemistry also encourages energy efficient process and the use of renewable eco-friendly resources to support sustainability and environment protection. To present this topic in detail, we are pleased to have Mrs. Chitra Periyasamy, is an associate research scientist at REST Labs in Kaveripattinam, Tamil Nadu, India. Chitra Periyasamy completed her Master of Science from Vinayaka Mission Research Foundation, Salem, followed by a Bachelor of Education from Pavai College of Education, Dharmapuri, Tamil Nadu, India. I now request Mr. Chitra Periyasamy to take the stage and enlighten us with their thoughts. Thank you, and over to you, ma'am.
Thank you for the opportunity. This is Sonia Sriram. Good afternoon all. Today I am pleased to talk about green chemistry. In important and particle approach to chemistry that focus on protecting our environment. It is great honor for me speak today on a topic crucial not only as science but also the future of our planet and our daily life. Green chemistry is about preventing pollution at the source rather than cleaning it up instead of dealing with harmful waste after it has been created. Green chemistry encourages scientists and industry professionals to design safer chemicals and process from outset. Green chemistry also aims to improve efficiency. It focuses on increasing the productivity to useful products while reducing waste, toxics, byproduct and energy consumption. This is achieved by changing the way in which chemicals are designed, manufactured and used. In short, green chemistry is about doing chemistry in a smarter, cleaner and more responsible way. The concept of green chemistry originated in 1991 when the US Environmental Protection Agency launched the alternative synthetic pathway for pollution prevention program. This program was created under the Pollution Prevention Act 1990. Unlike previous approaches that focus on controlling pollution after it occurred, this new program focused on reducing and eliminating the creation of hazardous substances. Later, the program expanded to include safer chemicals and environmental friendly solvents. In 1996, the term green chemistry was officially adopted. One of the key thinkers behind green chemistry was the American chemist Anastas. He believed that chemists improved the way chemicals were synthesized, pollution could be prevented before it even occurred. Together with another chemist, John Werner, he introduced the 12 principles of green chemistry in 1998. These principles several are clear guidance for safer and more sustainable chemistry. Some of the key principles include preventing waste, maximizing renewable feedstocks, and the use of catalysts to reduce raw material consumption. Chemicals should be designed efficiency process the use of renewable feedstocks, chemicals could be designed to break down in the harmful substance of after use, and real-time monitoring should be employed to prevent the formation of hazardous material. Above all, green chemistry promoted safer process to prevent chemicals. Green chemistry is grown rapidly. Today, green chemistry is recognized worldwide. Its importance was further understood in 2005 when the Nobel Prize in Chemistry recognized a scientific work as a scientific advancement in green chemistry. Chemistry has benefited society in many ways through medicines, plastics, phones and countless other products we use every day. However, many traditional chemical processes also genetic, toxic-based air pollution, water pollution and health hazards. Green chemistry does not mean stopping chemical development. It means doing chemistry in a smarter and safer way in purpose in production. Green chemistry is important for several reasons: environmental protection, chemical based on pollute barriers, soil and air. Green chemistry reduces harmful emissions and waste production, ecosystem and biodiversity. Human health and safety. Many chemicals cause skin irritations, cancer or long-term health issues. Green chemistry focuses on safer alternatives that reduce risk to workers, consumers and communities. Economic benefits. While some may think green chemistry is expensive, it saves money in the long run by reducing waste, therefore cost, saving energy, improving efficiency, avoiding regulatory patterns. Sustainable development. Green chemistry supports sustainable development, balancing interest, growth in environmental responsibility. For research laboratories and industries, green chemistry is not just a choice, it is become a necessity. Green chemistry, let's look at some clear and practical examples of green chemistry. Use of solvents, traditional solvents, chloroform or toxics. Green chemistry promoted safer alternatives. Water, ethanol, supercritical carbon dioxide. For example, dry cleaning once used toxic chemicals, but now many cleaners use liquid carbon dioxide or water-based systems. Catalyst ingest of excess chemicals. Catalyst increased reaction rate with being consumed. Using catalysts, energy consumes chemical-based reduction time. Natural catalysts like enzymes were widely used in green chemistry process. Biodegradable plastics. Convention plastic take hundreds of years to decompose. Green chemistry has introduced biodegradable plastics made from corn, stones, sugarcane or vegetable oils. These materials break down naturally, reducing plastic pollutions. Green synthesis of pharmaceuticals. Many pharmaceutical composites are now designing drug synthesis methods that use fewer tubes, produce less waste, avoiding toxic reactants. Renewable feedstocks. Instead of petroleum-based chemicals, green chemistry promotes use the renewable resources, vegetable oils, agriculture-based biomass. Green chemistry in everyday life, not just for research laboratories or industries. When truth we don't have a realize this already part of our daily lives. Green chemistry products, many old cleaning products today are made with plant-based ingredients, low toxic chemicals, biodegradable suspensions. Pharmaceutical and healthcare. Fewer side effect, cleaning, manufacture, process, reduce environmental effect. This benefits both patient and healthcare workers. Safer facilities, organic, reducing chemical, reducing food, energy and fuels. Biofuels like biodegradable and ethanol are product of green chemistry. They are cleaner and reduce greenhouse emissions. Solar cells and battery technology also benefit green chemistry research. Role laboratory in green chemistry. Research lab play a key role of advancing green chemistry. Under the guidance of experienced scientists like Dr. Ramachandran Manikam, innovative research can lead to safer chemical reactions, energy efficient process, sustainable materials. Core scientists like Mrs. Manjula Selvam contributed through experiment, design, process, optimization and innovations. At the same time, administration support from professionals like Mrs. Vimala Saravanan ensures smooth operations, compliance and responsible interest management. Green chemistry is successful only when science, management and responsibility work together. Challenges in green chemistry. While green chemistry offers many advantages, it also faces several challenges. High initial research, cost, need for new technologies, precedence to shifting from traditional methods, lack of awareness. However, these challenges can be overcome through proper training, policy, support and teamwork. Young researchers and students will play a crucial role in sampling this future. Green chemistry not just a scientific discipline, it is a movement towards responsibility and ethics in science. Green chemistry risks at the progress and safety can go hand in hand. It remains that scientific advancements should not come at the cost of human health or environmental damage. In our research laboratories, every experiment, every medical test and every process design is important by adhering to the principles of green chemistry were done. Reduce pollution, improve safety, conserve resources and create a sustainable future. Green chemistry is not just a scientific concept, it is a responsibility. It shows us chemistry can support economic growth while protecting human health and environment. By following the principles of green chemistry, we can create a cleaner, safer and more sustainable future. Thank you all for your time and attendance.
Thank you, Mrs. Chitra Periyasamy, for your and insightful talk on green chemistry, which focus on designing safer chemicals and a sustainable process that reduce hazardous substances, minimize waste, improve energy efficiency, and protect human health and the environment through eco-friendly and responsible chemical practices. We truly appreciate the time and effort you have taken to share your knowledge with us today. I am sure everyone has gained a deeper understanding and inspiration from your speech.